A warm welcome. This is Control Systems course lecture 2.4, which deals with root locus construction. A locus is the path which is taken by the roots, namely the poles or the zeros. Open loop poles or the zeros in the S domain is known as root locus. Root locus will represent whether the system is having a stable nature or not. Here we have two axes. One is a real axis, we call it as sigma, and we have an imaginary axis which is j omega. First, for drawing the or for constructing the root locus, we have to follow the following rules. The first rule is we have to locate the open loop zeros and poles in the S-plane. Then we have to mark them in that axis. Next, we have to find out the number of root locus branches. It means number of poles is equal to P and number of zeros is equal to Z. If both are equal, then there is no problem because all the root locus will be visibly present in the axis. It means the root locus will start at the open loop poles and they will end at the open loop zeros. So if P is equal to Z, automatically within the axis itself, the root locus will be starting at any pole and it will finish at a zero. But if suppose the number of poles is more, then the P is equal to Z, that Z number of branches will be known to us. These root locus will be starting and ending within the axis itself. And the excess poles, P minus Z value of branches will be starting from the pole because pole is present, excess pole is present, and they will end at infinite zeros. Similarly, if it is N is equal to Z, number of zeros is more than the number of poles, then in certain that cases number of poles will be the number of root locus branches which are available within the imaginary axis, that is finite poles and finite zeros completion, and the excess number of zeros will be present there, but the poles are inadequate. So infinite poles, the root locus will start from the infinite poles and it will end at the finite number of zeros. This is what is the case of drawing root locus in real axis. Next, rule 3, we have to identify a point in the real axis and then we have to view whether there is any odd number of poles and zeros existing to the left side of the point. If suppose there is an odd number of poles and zeros, then at that point what we have chosen, the root locus will be present, otherwise it will not be present. This is the condition which satisfies the root locus branch in the real axis. Fourth point, we have to find out the angle of asymptotes and centroid. Already we have seen based upon the number of poles and zeros how the root locus branches. Now using this formula, the centroid formula is nothing but alpha is equal to sum of the poles minus sum of the zeros divided by number of poles minus number of zeros. Since the complex conjugate poles and zeros will be getting cancelled automatically, they have given real part of finite open loop poles, real part of finite open loop zeros. Next, calculating the angle of asymptotes. Theta is equal to 2q plus 1 into 180 degree by p minus z. Let me tell you about angle of asymptotes. Asymptote is nothing but the direction of root locus, how the root locus has to travel, because we know it starts from a pole and it ends at a zero. Which pole and which zero, that's the main criteria which we have to find out. So we are drawing angle of asymptote to show the direction of the root locus. So the angle has to be marked at a base point. That point is known as centroid. With the varying two values, theta can be found out. This is rule number 6. While considering number 6, we have to find out the breakaway and break-in point. Breakaway or break-in point, what does it mean is, if we are considering open loop poles, then there will be a breakaway point. When we are considering open loop zeros, there will be a break-in point. What is the meaning of breakaway or break-in? For example, in real axis, if we are having two open loop poles in the real axis, adjacent poles are present in the open loop real axis. Then we know the root locus will start from the poles. So what condition is, there will be two root locus. One locus will be starting from one pole and the other locus will be starting at another pole. What both the poles have, both the root locus have to do is, they can't travel through each other. So what they will do is, they will intersect at a point called breakaway point. The word is breakaway because they have already started. The root locus has started from the poles and they are traveling towards each other to the breakaway point. At the breakaway point, they will intersect each other and they will started to travel in two different directions through which they have to pass through in order to reach their respective open loop zeros. If suppose in the real axis two open loop zeros are there, then the root locus from some other poles somewhere else, the poles may be at infinite or finite, the poles, the root locus from the poles, they will be traveling towards the open loop zeros, but there are two open loop zeros adjacently. At that time, those two root locus will reach a point known as break-in point, and they will start traveling towards their respective open loop zeros. This is the condition actually, and how we have to find out is simple. We have to take the characteristic equation, equate it to 0. You then take the value of k from the characteristic equation. You frame the value for k, differentiate it once and equate it to 0. Automatically you will be getting some points where those roots when substituted in the characteristic equation, they have to provide positive values. In such a case, those roots can be considered as, those values can be considered as breakaway or break-in points. And the last one is rule 7, where we have to find out the angle of departure and angle of arrival. Why we are finding out angle of departure or angle of arrival? So now we have directed the root locus. We have drawn the asymptotes and we have directed the root locus to go through. But they will be arriving at a point. If suppose there are complex conjugate poles and zeros, then what does the root locus, which is starting from a complex conjugate pole, will do? How it will go? At that point, it requires an angle of departure. Angle of departure in the sense at what angle they have to take, and they have to travel along the direction of asymptotes. Similarly, if a complex conjugate 0 is present, then the root locus will be coming from somewhere else. From infinite, it will be coming through the asymptote, and then it will be reaching, it has to reach the complex conjugate 0, but at what angle it has to reach, that angle is known as angle of arrival. So what we used to do is, we used to find out using this formula, phi d is equal to 180 degree minus phi, and angle of arrival phi a is equal to 180 degree plus phi. How phi value is calculated is very simple. If we are considering a complex conjugate pole, we have to find out at what angles the other open loop poles are being subjected to this open loop poles, that is, and we have to add it, that is sum of phi p. Similarly, what and all the zeros are present, and those zeros are how much they are tendered, at what angles they are tendered towards that particular open loop pole, that summation will give you phi z. That difference makes it phi. So this phi can be subtracted from 180 degree in case of angle of departure, and it has to be added to 180 degree in case of angle of arrival. By this manner, if we draw the root locus and complete its path, we can draw a root locus easily for any question. Thank you.